Okay guys, today we're going to be solving this optimization problem to find maximum area. So the problem says, a rancher has 400 feet of fencing with which to enclose 2 adjacent rectangular corrals, see figure. What dimension should be used so that the enclosed area will be a maximum? So to start off, I'm going to start by drawing out these corrals from a bird's eye view. So you can see the figure from overhead. When we do that, we can see we have one side that's y, two sides that are x each. So if we were to fill in the remaining missing sides, we'd have y here, x here, and x here. Looking at this figure now, we can see we have 4 x's and 3 y's. We know this will equal to the total length of fencing of 400 feet. So we can write 4x plus 3y equals 400. This is our constraint. It's our secondary equation. So we know we're going to substitute one of these values for each variable into the other equation. So I'm going to go ahead and solve this equation for y. I would get y equals 400 minus 4x divided by 3. Now we're trying to maximize the area, so I'm going to go ahead and write down the equation for area of a rectangle, which is length times width. And in this case would be equal to x, or 2x, times y. We can now substitute in what we have solved for y into this equation. Take it from our secondary, our constraint equation. We can now write this is equal to 2x, open parentheses, this expression, 400 minus 4x over 3. We can then distribute this 2x term to both of these and break up this fraction into 2 separate fractions. We would have 800x over 3 minus 8, 2x times 4x is 8x squared over 3 again. We're now going to differentiate this area equation with respect to x and set it equal to 0 to optimize. So this will become equal to 800 over 3. The derivative of x is just 1, so that's implied, minus 8/3. The derivative of x squared is 2x. 2x to the 1 power is just 2x. And this is now equal to 0. So simplifying, we have 800 over 3 minus 16x over 3 equals 0. We can now multiply both sides by 3 to cancel our denominators. Multiply by 3, multiply by 3. On the left side, the 3's will cancel with our denominators of 3. On the right side, 0 times 3 is still equal to 0. So this now leaves us with the equation that 800 minus 16x equals 0. We can move the 16x to the right side of the equation. We have 800 equals 16x. We can then divide both sides by 16. On the right side, the 16s will cancel. On the left side, we can now go to our calculator, and we get x is equal to 50 feet. Now we can go back and solve for y. Remember, recall y up here is equal to 400 minus 4 times x, which is 4 times 50 now, divided by 3. So in this case, y is equal to 400 minus 200, which is simply 200 divided by 3 feet. So there we go. We've optimized for the area. When dimension x is 50 feet and dimension y is 200 over 3 feet, we've achieved maximum area for the two corrals.